Hi guys, my name is TL. Welcome back to the Tutoring YouTube channel. Today, I'm going to be going over some geometry problems with you, and I've got a collection of 4 questions that test triangles, polygons, and these 2 are circles. And I've got the reference table just in case it comes handy. So, without further ado, let's begin. Line L is parallel to line M. That's the first thing that they give us. And segment BD is perpendicular. Segment AC and BD intersect at E. We don't really need to know about that since it's marked. What's the length of this is what we're looking for, the segment of AC. So AC can be represented by the length of AE plus EC. And if you think about it, if we draw this on our triangle, this is one part of AC, and then the next part of AC would be this EC part, this yellow part. Let me change the color a little bit. This red and green part would represent AC. So that's what we're trying to find. Now let's first try to find AE. So we already know that this side is 12 and this side is 5. Um, but there's one thing that we're missing is this right angle. And now with this right angle complete, um, then we also know that these are right angles. And in order to understand why, DB can be seen as transversals to the set of parallel lines. So first we mark the parallel lines, and then we know that any line that crosses through will form alternate interior angles, and those alternate interior angles um, will be congruent to each other. So this would be congruent to that one, and this would be congruent to that one. In this case, if they're 90, they're all just going to be 90. So now let's continue. So now we have a right triangle, we could use the Pythagorean theorem. So it's going to be 5 squared, 25, plus 12 squared, 144, 169. And that's going to be a squared plus b squared is equal to c squared. In order to find c, which is the hypotenuse, we take the square root, and we get 13. You could also recognize this as a 5, 12, and 13 triangle, a Pythagorean triple, but yes. Next, the next part we need to get is EC. So EC is actually the hypotenuse of the small triangle that's formed over here. And then we have information that this side length is 1. So the height of the triangle in this case is 1, the smaller triangle, and the height of the bigger triangle is 5. So we know that all the sides from the bigger triangle are going to be 5 times as big as the smaller triangle. In other terms, we could say that any side on the smaller triangle is going to be 1/5 of the bigger triangle. So let's do that. So that's going to be 5 times 1/5 is equal to 1. And then now let's do the same for our hypotenuse since that's what we're looking for. So let's add them together. This is our EC that we were looking for before. So AC is equal to 13, which is the hypotenuse of the bigger triangle, plus the hypotenuse of the smaller triangle. And then we get and now what I basically did was multiply by 5 in order to get a common denominator. And then now let's add the fractions, and that's our final answer. Next, we're given a figure, a regular polygon with 9 sides, divided into 9 congruent isosceles triangles by line segments drawn from the center of the polygon to its vertices. What is the value of x? So since the value of x is over here, we're not really going to worry about the other sides since we all know they're going to be the same. So in order to draw, in order to mark our diagram, we're just going to draw congruent marks on the 2 sides of the triangles since we know that if it's isosceles, then 2 sides have to be congruent to each other. So once we know that this side is the opposite side of x, and we also know that this side is going to be x also. And how we know that is because the sides are going to be congruent, And with congruent sides, we have congruent angles opposite of them. So next, let's find um, y. And I'm going to say y is this. We just like make three variables, or two in this case, x and y. So the sum of the angles in a triangle is 180. Okay, so this is actually going to be a simplified form of x plus x plus y. So y is going to be 360 divided by 9. And how we got that is because in order to go around a point completely, you must make one full rotation, or 360. And since the polygon is split into 9 congruent triangles, then we could just say that the angles are split up evenly among these 9 triangles. So that's going to be 40 degrees. And that's just going to be y because y is up here and the x's are down there. So next, what we're going to have is 180 is equal to 2x plus 40 degrees. And then now we have 140 is equal to x. X is equal to 70 degrees. So this one, 70 degrees, and also this one too, actually. So both of them are going to be 70 degrees. Next, we are working with circles now. In the figure above, angle x AXB. Okay, let me mark that. AXB and AYB. So recall from geometry that if you have angles inscribed within a circle, such as AXB and AYB, that their measure is going to be equal to the arc that is opposite of them. So in this case, it's arc AB over 2. So since AYB and AXB are both connecting or inscribed or opposite against the same arc, which is AB, then we can infer that they're going to be equal. Okay, so if we look at AXB, the arc that's facing opposite of the angle, which is here, is going to be AB. And if you took an AYB, it's going to be the same case. So they're going to be equal, actually. Oh, that's not it. C. Okay. Next, we're going to look at areas of a certain area. Areas of a certain area. Areas of a certain region, like a shaded region like this one. So yeah. So how we could think about this, actually, let's just read the problem first. In a given figure, O is the segment of the circle. Segment BC is tangent to the circle at B, and A lies on the segment OC. If OB and AC are equal to 6, then what is the area of the shaded region? Okay, so OB 6, AC 6. Now, one more side that we know is actually going to be OA, since in a circle the radius is going to be constant throughout. That's what makes a circle perfectly uniform. So this is going to be 6 also, because just like I said before, the radius or the center to the ends, they're going to be the same distance apart. Next, what we have to mark is the segment BC is tangent. So we draw a right box, or like a square box, to indicate that not only is it perpendicular, but it is also a right angle. So whenever you hear the word tangent, think of perpendicular lines and think of 90-degree angles. So now we pretty much have everything set up. What we're going to do now is add the 6 and 6's in order to get the hypotenuse, which is opposite the largest angle in the triangle. So now what we're going to do is 6, x, and 12. And now the reason why I leave it like this, it's because there's a special pattern that is going to be present. Um, if I were to look in the reference table, I see that there's a section on triangles, and in the other triangle that we had, it was 6 as x, right? It was the height, and the hypotenuse is actually 12, so h is equal to 12, or h is equal to 2x. So in this case, we actually have a special right triangle, and it's called the 30, 60, 90 triangle. So we already know the value of the other side. It's going to be 6 rad 3. Now let's say you didn't have um, access to the reference table, or you just forgot. Now the other way you could do it is the Pythagorean theorem. 144, which is 12 squared, is equal to 36, 6 squared, plus x squared. So now what we have to do is x squared is equal to 108. And then now we have to find um, factors that go into 108 that are easily squarable. So it's going to be 36 times 3, oh, rad 3, sorry. And then that's going to be 6 rad 3. So obviously, if you become familiar with the reference table, um, it'll help you a lot in these scenarios. So our side is actually 6 rad 3. So let's bring it back up here. So the area of the triangle is going to be 1/2 base times height. So in this case, the base is going to be 6 rad 3, and the height is going to be 6. So our area of the triangle is going to be 18 rad 3, but that's not the area of the shaded region. That's just the area of the entire triangle. What we have to do now is erase this blank white region from, or the region from the circle from the triangle. So in order to do that, we need to find certain angles. So in a triangle, the larger the angle, the larger the side opposite of the angle is going to be. So in this case, if this is 6 rad 3, that's obviously going to be bigger than 6. So we could say that this one is 60 degrees and this one is 30 degrees. And now we're pretty much done. So in a circle, in order to make one full rotation, we had 360 degrees of rotation. So see 360 over, oh no, 60 over 360, that's equal to 1/6. And now this represents 1/6 of the area of the circle. So now let's do that. The area of the circle. A is equal to pi r squared. A is equal to pi. Plug in the value for r, which is 6, as we found here. That's just 6 squared. So 36 pi times 1/6. And the reason why I multiply by 1/6 is because we're only finding the area of the sector, and since the angle is actually 1/6 of the entire circle, the area is just going to be 1/6 also. So then we have 6 pi. So the area of the sector is 6 pi, and the area of the triangle is 18 rad 3. So let's just subtract the area of triangle, area of circle, sector. And that's it. That's how we find the area of the shaded region. So if you have any questions, leave them in the comments below. If you want to apply to become a student or a tutor at Care Tutoring, please feel free to check the links in the description below. And that's all I have for today, and see you guys next time.